Hi everyone, good evening. Welcome to Manorama Horizon free revision classes. Okay, today we'll be starting the first chapter in class 10th, chemical reactions and equations. Can you hear me? Okay. Once again, good evening to all. Okay, we'll start. So, in this chapter, we'll be learning what is a chemical reaction and how to balance chemical reactions. Okay, that is the first agenda of our student. Discuss completely what is a chemical reaction and how to balance chemical reactions. So that then we'll learn and understand the different types of chemical reactions. Okay, in class we have already studied different types of chemical reactions and examples for those. Okay, we'll be revising that once more. And at last, we will see oxidation reactions in everyday life. Okay, so let's start. So we'll see what is a chemical reaction. So we have already learned that in a chemical reaction, substances get transformed. Okay, so while transforming these substances, there are certain changes that will occur in the chemical reaction. So what all kinds of chemical changes, what all transformations that are taking place, all these things we will be discussing in detail in this class. Okay, so what are chemical reactions? We will see. So in a chemical reaction, what will happen? This chemical substance gets transformed into another substance. So that is what happened in a chemical reaction. We will see some of the examples. So rusting of iron is a chemical reaction. Then settling of milk into curd. We are usually seeing this reaction in our home, right? So we are settling milk to become curd in home. And also digestion of food, that is another chemical reaction that takes place in human body. And not only human body, in animals also. And respiration. Respiration is another chemical reaction. Okay, so these are the chemical, some of the examples for chemical reactions. So we told that in chemical reaction, one substance will change to another substance. Okay, so that's why we are telling it's a rearrangement. So in a chemical reaction, what happens is a rearrangement of atoms takes place. Okay, so if you are facing any doubts or if you're facing any doubts for understanding, you can put message in the chat box. If you want to tell something, you can keep posting on chat box, that I'll unmute, and that time you can speak as well. Okay, so we told that in a chemical reaction, what happens? Rearrangement of atoms takes place. So the substances that takes part in a chemical reaction, we call them as reactants, and the newly formed substances, no? So that we will call as products. So here we can see an example of a chemical reaction. So burning of magnesium in the air to form magnesium oxide. So magnesium reacts with oxygen, forming magnesium oxide. So see that chemical equation. We can see, no? So chemical symbol of magnesium is Mg. Okay, that we need to understand. So Mg is the chemical symbol of magnesium. Mg reacts with oxygen. Oxygen, it is occurring in bimolecular state. Okay, it's a diatomic molecule. We know that. So magnesium reacts with oxygen. And why we have not given Mg2? Magnesium is monoatomic. Okay, that's why we have given Mg. Mg plus O2 gives 2 MgO. So that's the reaction. Magnesium oxide is the product formed. So when we are seeing this chemical equation, we can see that there is an arrow. You can see that there is an arrow, right? So that arrow is known as forward arrow. So chemical reactions we will represent using reactants, products, and as well as an arrow will be there in between. So above that arrow, we can see a symbol. Okay, this symbol that we will call it as delta. Delta. Okay, delta means that is a sign of heat. So in this reaction, magnesium reacts with oxygen in presence of heat. Okay, we'll get magnesium oxide. So burning of magnesium is accompanied by release of large amount of heat. So that is given in that equation. So we can see that reactants are there. Reactants are magnesium and oxygen, and the product is magnesium oxide. So this is an example of a simple chemical reaction. Okay. Okay. So we told in the beginning itself, chemical reactions are taking place with a lot of characteristics. Some chemical reactions, we can see that gases are evolving. In some other chemical reactions, we can see that color change will happen. So like that, chemical reactions are happening with a lot of characteristics. Okay, first we will see the evolution of gas. How gases are evolved in chemical reactions. We will take that as an example. Okay, so chemical reaction between zinc and dilute sulfuric acid is characterized by the evolution of hydrogen gas. Okay, so in this reaction of zinc and dilute sulfuric acid, we will get hydrogen gas as the one of the product. We will get zinc sulfate also, but it will be in solutions. It will be in solution, and hydrogen gas, it is formed. It will be coming out of that test tube. We can see that in that figure. Okay, zinc plus sulfuric acid gives zinc sulfate and hydrogen. So in this reaction, evolution of gas is taking place. And also, one more thing we need to remember here is zinc is a metal, right? H2SO4 is acid. In acids and bases, that lower classes we have already studied, but metals react with acids forms hydrogen. So this is an example for that kind of reaction also. Chemical properties of acids. So zinc reacts with sulfuric acid, we will get zinc sulfate and hydrogen. Okay, so is this SO4 group? No, we will call that group whole as sulfate, SO4. So we will see the next characteristic of chemical reaction. So change in color. So change in color is another characteristic of chemical reaction. So what will happen to citric acid when we are adding some potassium permanganate to it? So what will happen is potassium permanganate is having purple color, we know. So if you are adding citric acid, then color changes. That purple color fades in that reaction. So change in color is a characteristic of a chemical reaction. Okay. The chemical reaction between sulfur gas and acidified potassium dichromate. I'll tell you one thing. Color of potassium dichromate is orange. Okay. If you are adding sulfur dioxide to potassium dichromate solution, what will happen? The color will change to green. So in some reactions, what will happen? The color change will happen. Okay. In some reaction, we told gases will form. In some other chemical reactions, color change will happen. Okay. So we'll see the next. In some other reactions, what will happen is state of the substance will change. Okay. For example, we will take candle wax. Okay, if we are lighting the candle, what will happen? That wax will become liquid. Okay, we know that wax is a solid. So solid will changes to liquid. Then what will happen? Then after that, gas will also form out of this. Okay, so wax is a solid, but the water formed by the combustion of wax is a liquid at room temperature, whereas carbon dioxide produced by the combustion will be a gas. Okay, so change in the state of the substance takes place in some chemical reactions. Okay, understood? So next is change in temperature. So in some chemical reactions, what will happen? Temperature will change. Okay. For example, if we react quicklime and water, if we are adding water to quicklime, what will happen? We will get silicate lime. So that chemical reaction is like this only. Quicklime is calcium oxide. Okay. Calcium oxide plus water, H2O water, we will get calcium hydroxide. So calcium hydroxide is silicate lime, CaOH twice. So this is a reaction, but a lot of heat is also generated along with this. Okay. So that is a reaction which is an example for change in temperature. In addition, we have some other reaction too, in which zinc granules and dilute sulfuric acid reacts. Okay, in that reaction also we will get zinc sulfate, but reaction is characterized by a rise in temperature. Okay. Okay. Saindavi has asked a question. Okay. Okay. One thing we need to understand here is we need to. She's asking like calcium hydroxide formed will be liquid or aqueous. Obviously, it will be aqueous. Okay. It will be the phase will be aqueous. Okay. So calcium hydroxide formed will be in aqueous phase. And if we are writing a chemical equation, we need to have the phase also in brackets. So that is another characteristics of this writing chemical equation. Okay. So it will be in aqueous phase, because why I will tell you, like if we are doing any reaction in water, the product formed will be soluble, or sometimes it will form precipitate. If it is forming precipitate, it will be substance, the formed substance will be solid. But if it is dissolved in water, it will be in aqueous. So we are calling a solution as aqueous solution when if that product formed is dissolved in water. If the product formed is dissolved in water, then we will call that as an aqueous solution. Okay. So the product formed will be in aqueous phase. So if you know that calcium oxide, it is solid, water is liquid, we will get the product in water. So we will call that as aqueous. Understood? Okay. 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 Now let's proceed. So remember this. If any reaction that is happening in water, the products formed, if it is not a solid, then phase will be aqueous. If it is a gas, phase will be gaseous. But if it is dissolved in water, aqueous is a phase. So we are calling a solution aqueous if it is dissolved in water. Okay. So let's proceed. The next characteristic is the formation of precipitate. Okay. In some reactions, precipitate will form. Precipitate means that solid particles, no, solid granules, or sometimes solid powdered form. It like that it will form. So the chemical reaction between sulfuric acid and barium chloride solution is characterized by the formation of white precipitate of barium sulfate. So this barium sulfate, it is insoluble in water. So that remains a solid. Here we can see that always H2SO4 and all, it will not be liquid. We are using highly diluted solutions of sulfuric acid. So barium chloride solution, if you are treating with sulfuric acid solution, both will be in aqueous phase because we are dissolving barium chloride in water. So that we will get aqueous barium chloride solution. Then we will add hydrogen sulfuric acid to it. Sulfuric acid we are preparing in labs by adding water. Like we will add sulfuric acid to water. So like that only we are preparing sulfuric acid. So it will also be in aqueous phase. But if we are doing that reaction in our test tube, we will get a precipitate of barium sulfate. In addition to that, HCl will also be formed in that reaction. So like that, formation of precipitate. That is also a characteristics of this chemical reactions. Okay. So do you have any doubts till now? Like we have discussed the formation of precipitate, change in temperature, change in state, change in color, and evolution of gas. These are some of the characteristics of chemical reactions. Do you have any doubts here? Okay. Okay. We have a question like a simple chemical equation for change in state like solid plus solid gives gas or something similar. So phase change. Okay. Simple example for a phase change is that we can tell us naphthalene balls, you know, right? So naphthalene balls, what will happen to naphthalene is it will directly from solid to gaseous state it will go. Okay. Okay. So that is a simple reaction that we can give here. Okay, I'll write it here. Okay, naphthalene, it is in solid state. So it will, if we are keeping that in a room, it will go to gaseous form. This is an example for sublimation reaction. So here we can find the state change happening, and also we can tell in the case of water. So H2O solid, that we call it as ice. No, ice will go to, actually this reaction is reversible. Ice will go to water, then water will go to vapor. So this is another example in which phase change happening. Okay. And also other chemical reactions are there. Formation of water also we can take. Okay. H2. Phase is in gas, right? We know that. Also O2. Oxygen is also in gaseous state. Product formed will be H2O. H2O will be in liquid phase. Okay. So phase change. We can see here now. Phase of the substance. State of the substance is getting changed. So hydrogen is in gaseous state, oxygen is in gaseous state, but the water formed will be in liquid state. That is also change in state. Reactants state is different, and the state of the product formed is also different. Okay. Balanced chemical equation. So in the case of water, we can give that balanced chemical equation. Yes, ammonia. Yes, we can use ammonia and HCl. We will get ammonium chloride as a product. Okay. Okay. So NH3 plus NH3 is in gaseous state. Okay. Plus HCl. HCl is in aqueous state. Or we can use HCl in gaseous state also. Product formed will be ammonium chloride, NH4Cl. So it will be NH4Cl. So this is a balanced chemical equation. Number of nitrogen atoms is 1, hydrogen is 4, chlorine is 1. Okay. So we can use ammonia also. Ammonium, if we are using HCl aqueous, the product formed now, NH4Cl will also be in aqueous phase. So these are some of the examples. Understood? Okay. Okay. Can you explain the reaction of quicklime? Okay, quicklime, Archa, we will discuss. We will see quicklime, reaction of quicklime also. Okay. So this is clear, right? Gases are evolving. Then the second one is change in color. So we discussed this change in state and temperature. So we will see. So quicklime reaction, chemical reaction between quicklime and water. So quicklime chemical formula is calcium oxide. Okay. CaO. Calcium oxide is quicklime that is in solid state. Quicklime reacts with the water. It's telling like chemical reaction between quicklime and water. Water chemical formula we know that H2O. H2O that is in liquid state. Water is in liquid state, we know, right? When we are reacting calcium hydroxide and water, we will get calcium hydroxide. The calcium hydroxide is a flaked lime. We will call calcium hydroxide. This is calcium hydroxide. Calcium hydroxide. So we'll call this calcium hydroxide as flaked lime. Common name, okay? Flaked lime. So calcium oxide reacts with water, forming calcium hydroxide. So we need to understand here, when we are reacting calcium oxide and water, we will get calcium hydroxide, which is in aqueous state. Why aqueous means if we are dissolving any compound in water, the resulting solution, we will call it as aqueous. Okay. So if we are dissolving a compound in liquid water, we'll call it as aqueous. If we are using some other solvents, we know apart from water, we are having so many other solvents like carbon tetrachloride, normal hexane. These are all solvents, but we will not call these products formed as aqueous. And will be in different phase. This aqueous is given exclusively for the solutions in water. Okay, this one also we need to understand. Okay. Okay. As of now, is everything clear? Do you have any other doubts on this? Okay. Okay, then let's proceed. So we already told that what is a chemical equation, how we will represent the chemical equations. These things we have already discussed. Okay. So generally we can represent like this: A plus B giving C plus D. A and B are reactants and C are and D are products. So we will represent this one by using an arrow. We will usually call this one as forward arrow. Above that forward arrow also we can give some conditions, reaction conditions, or if some solvents we are using, then we can keep above the arrow. Okay. So like that, we will use represent with different arrows. Okay. Equilibrium type reactions we will be representing with double-headed arrows. So different types of arrows we will study in future classes. So now we know that reactants and products we are representing in chemical form. That is our chemical equation. So this is a form of a particular typical chemical equation. So now we have an example for water, for how the formation of water takes place. Hydrogen reacts with oxygen, forming water. H2, we know that H2 is in gaseous state. It reacts with oxygen, which is also in gaseous states, to form water. Okay, in the first equation, words are used. We know that we have written in words only: hydrogen plus oxygen gives water. So every time we cannot use this long names, right? If it is ammonium chloride and all, practically it is not possible to use chemical names always. That is why we are using chemical symbols to represent these chemical reactions in a chemical equations. Okay. Then, so we can divide chemical equations into two types: balanced and unbalanced chemical equations. So in a balanced chemical equation, what will happen? Number of atoms in the reactant side will be equal to the number of atoms on the product side. So that is a balanced chemical equation. So here in this equation, we can see that number of zinc atoms in reactant side is 1, number of zinc atoms in product side is also 1. Then considering hydrogen atom, there are 2 hydrogen atoms in reactant side, product side also, there are 2 hydrogen atoms. See, 2 hydrogen atoms. Then considering that sulfur atom, there is 1 sulfur atom in reactant side, product side also we have only 1 sulfur atom. Oxygen atoms, there are 4 oxygen atoms in the reactant side. Similarly, 4 oxygen atoms are there in the product side. So this reaction we will call it as a balanced chemical equation. Number of atoms, each atoms we will consider. So number of atoms on reactant side will be equal to the number of atoms on the product side. Then we will call that reaction as balanced chemical equation. Okay. Now balanced chemical equations, hope you have understood. Do you have any doubts over here? If you have some doubts, tell me, okay? We will rectify doubts and we'll move on. Okay, let's proceed then. So we'll see what is an unbalanced chemical equation. So in this reaction, we can see that Fe stands for iron. Fe, there's only 1 Fe in the reactant side, but we are seeing the product side, we can see 3 Fe atoms. So it's not balanced. So it's an unbalanced chemical reaction. So when we are checking on the both sides of the arrow, the number of atoms are differing, then it is unbalanced chemical reaction. Okay. So now we'll see there are different kinds of chemical reactions are there. Okay, we'll see different kinds of chemical reactions. So first one is the combination reactions. If 2 components, 2 or more reactants react together to form different types of products. So that that kind of reaction, it is known as combination reactions. Two or more reactants react together to form a product, to form a particular product. Here, magnesium and oxygen are reacting to form magnesium oxide. So that is an example of combination reaction. Similarly, carbon reacts with oxygen to form carbon dioxide. That is another type of combination reaction. So in general, we can tell that a particular reactant A reacts with reactants B to form product AB. So that is combination. It is like combining. Okay. So next type of reaction is decomposition reaction. In a decomposition reaction, what will happen is this AB, that is a reactant. AB. We can mention this as A is bonding with B. So AB decomposes to A and B. We will get two different products, A and B. So that is known as a decomposition reaction. In a decomposition reaction, a product decomposes to smaller products. Okay. So this is a decomposition reaction. We can have an example of calcium carbonate. Calcium carbonate decomposes to form calcium oxide and carbon dioxide. This is a common example that we are using for decomposition reaction. Okay, I'll write it for you. Calcium carbonate, CaCO3, decomposes to form. The reaction happens in the presence of heat. We'll get calcium oxide and carbon dioxide. So calcium carbonate, that is marble, that is in solid state is solid. Calcium oxide formed will be solid, and the carbon dioxide formed will be in gaseous state. So this is a common example for the decomposition reaction. Calcium carbonate gives calcium oxide plus carbon dioxide. Okay. So this is decomposition reaction. So we'll see there are three different types of decomposition reaction: thermal decomposition, electrolytic decomposition, and photo decomposition. Okay, in thermal decomposition, the decomposition takes place by the use of heat. So considering electrolytic decomposition, if decomposition happens by the use of electricity, then we will call it as electrolytic decomposition. If we are using light for the decomposition of a substance, then we will call it as photo decomposition. Okay. So there are mainly three types of decomposition reaction based on based on the mechanism by which the decomposition occurs. So first is thermal, we told calcium carbonate decomposition. It is an example for thermal decomposition. Then water, decomposition of water. That is using electricity. That is electrolytic decomposition. If the decomposition is taking place using sunlight. In the case of silver chloride, AgCl. Ag is the chemical name of silver. Okay. Silver chloride decomposes in presence of sunlight, gives silver and chlorine gas. Okay. Do you have any doubts over here? Shall we proceed? You are getting a okay, let's proceed then. If you have any doubts in between, you can ask. Okay. So next is the double displacement reaction. Reactions in which ions are exchanged between reactants forming new compounds are called a double displacement reaction. Okay, in double displacement reaction, we are having two different particular reactants, and the ion exchange takes place between these reactants. So we can have an example of reaction of which reaction we will give. We will give example for double displacement reaction. H2 CuSO4 plus copper sulfate. or else we will wait 1 second. Okay. We'll write that equation for double displacement reaction CuSO4 plus, sorry for a bit inconvenience. Okay, CuSO4 plus HCl. We will get CuCl2 plus CuCl2 plus H2SO4. H2SO4. So we can see here the sulfate ion. No, it was with copper initially. Now it is with hydrogen. So exchange of ions. Cl was with hydrogen initially. Now it is with copper. So ions are exchanged. CuSO4, how it will become ion? CuSO4, we can write it as Cu2 plus and SO4 2 minus. Okay, so copper sulfate in aqueous phase, it will be like Cu2 plus ion and SO4 2 minus ion. So this Cu2 plus ion will get Cl minus. CuCl2, it is Cu2 plus, and there are 2 Cl minus, right? So it is 2 Cl minus. This 2 Cl minus will go with the copper. So like that, exchange of ions takes place in double displacement reaction. Understood? Shall we go? Yes. Dikshit, double displacement reaction. So yes, the reaction between lead nitrate PbNO3 and Ki, that is also a double displacement reaction. So what will happen? We'll get PbI, PbI2 and KNO3, potassium nitrate we will get. KNO3, that is a formula for potassium nitrate, and we'll get PbI2. Actually, lead is having different valences. Pb2 plus is also there, Pb4. So there are chances like we'll get Pb2 plus, no, and Pb lead will occur in, commonly it is in 2 plus oxidation state. Sometimes it will be in +4 oxidation state. PbCl4 compounds are there. Okay, here PbI2. I2 will be forming, and KNO3. Potassium nitrate, we will write KNO3 only because potassium is having the valency +1. It is the group 1 element, right? So it is having only one valence. And NO3 is having, NO3 is a polyatomic ion which is having only one negative charge. So like this only, that reaction will occur, then we can balance. Okay, that reaction will occur. That is also an example for double displacement reaction. Good, Dikshit. Okay. So we'll proceed further. Hope you are having no doubts. Okay. So Here we are having some examples for double displacement reaction. Barium chloride with sodium sulfate, we will get barium sulfate and NaCl. That is an example of double displacement reaction. Also, sodium hydroxide reacts with HCl, gives sodium chloride and H2O. That is also a double displacement reaction. Okay. Usually precipitation reactions are double displacement reactions, and also neutralization reactions are also this double displacement reactions. We can see that this barium sulfate, it's a solid, right? So it's a precipitate. Barium sulfate is a white precipitate. So it's an example for a precipitation reaction as well. So it's a double displacement reaction. If in a reaction precipitate is formed, then we will call that reaction as precipitation reaction, because the precipitate is formed, right? That's right. So then neutralization reaction. When a base is reacting with an acid, we call that reaction as neutralization reactions, because always we will get a salt and water as the product. We can see here NaCl is the salt and water. So salt and water, if we are getting as products, when a base reacts with acids, then we'll call that reaction as neutralization reaction. Okay. So we can see images for precipitation and neutralization reaction. So neutralization reaction, acid react with base forming salt. In precipitation reactions, we will get a solid precipitate. Okay. So in the case of barium sulfate precipitate, we see that barium chloride is reacting with sodium sulfate. Na2SO4 is sodium sulfate. It is forming barium sulfate precipitate and NaCl in aqueous form. Because all other reactants we are taken in aqueous form only. So we have to note that one also. Okay. So these are the important types of chemical reactions. In addition to that, we will see what is oxidation and redox reactions. So in all of these type of reactions that we have discussed, we can see that oxidation and reduction occurs. Okay, we'll see what is an oxidation reaction, what is a reduction reaction, what is an oxidizing agent, what is a reducing agent. These things we will see now. Okay. Till now, do you have any doubts? Do you have any doubts till now? If you have any doubts, means we will see that and we'll proceed. Okay. Displacement reaction, you are having doubt, huh? Archa? No doubts? Okay, Archa, do you have any doubts regarding displacement reaction? Okay, actually, I'll tell you. Displacement reactions are of two types. That is single displacement and double displacement. Okay, that we will study in class 11 or 12. I'm not sure when. So we will study that. Okay, as of now, we have to keep in mind like how. Okay, for Archa, I am telling you again what is a double displacement reaction. Okay, I will tell you with examples. Okay, so in a double displacement reaction, what will happen? Some of the ions will get interchanged. Like we have reactants, right? So in the reactants, we can treat that reactants as ions. So barium chloride, if you are taking barium chloride as the reactant, it is having two types of ion, barium and chloride. Ba2+ ions will be there and Cl- ions will be there. Okay, so for barium chloride, 2 ions will be there. Similarly, for sodium sulfate, 2 types of ions will be there. Na2SO4. In 2 Na+ ions will be there and SO4, 2- ion will be there. So what will happen in a double displacement reaction? These ions will get interchanged. So while interchanging, what? Barium got sulfate ion and sodium got chloride ion. So like that, interchanging of ions takes place in double displacement reaction. Here, both reactants, that interchange happened, right? That is why we are calling this reaction as double displacement. 2 times it's happened. So with barium, sulfate ion came. Similarly, with sodium, chloride ion came. Okay. So 2 times displacement happens. That's why we are calling this reaction as double displacement reaction. So we are telling precipitation reaction is an example of double displacement reaction. Also, neutralization reaction is an example of double displacement reaction. Okay, now it's clear, huh? Okay. Good. We will proceed. Okay. So we'll see now what are oxidation reactions and what are reduction reactions. So in a reaction, if we are adding oxygen or a non-metallic element. Non-metallic elements means those we can see in that right side of the periodic table. That is non-metallic elements. Okay. So if we are adding oxygen or a non-metallic element, or if we are removing hydrogen or a metallic element from a compound, we call it as oxidation. We can say in this example, magnesium reacts with oxygen. Oxygen is added. So that reaction is a oxidation reaction. Okay, addition of oxygen takes place. That is why it's an oxidation reaction. Okay. So we will call like magnesium is oxidized to magnesium oxide. We will tell like that. Okay. So that is oxidation reaction. Now remember this thing, addition of oxygen or non-metallic element. Otherwise, if we are removing hydrogen or a metallic element from a compound, we call it as oxidation. And the substance which undergo oxidation, we call it as a reducing agent. Okay. Okay, I'll tell you here in this case. Okay, magnesium, it is having oxidation state 0. Okay, it is in elemental state. It will become magnesium oxide. Oxygen is added, right? So oxidation happened to this magnesium oxide. Magnesium. So magnesium oxidation occurs. This is oxidation. So magnesium, we can call it as a reducing agent. Okay. Reducing agent. So if a reactant undergoes oxidation, we call that reactant as the reducing agent. This much thing you keep in mind. Okay. The remaining we will discuss now regarding reduction, how it is coming. Okay. So these are some of the examples for oxidation reaction. If we are adding oxygen, it is a oxidation reaction. Here, carbon plus oxygen gives carbon dioxide. That is oxidation of carbon. Similarly, Fe plus sulfur. Sulfur is a non-metallic element, right? Electronegative element. Then we will get FeS. That is oxidation of iron. If you are removing an electropositive element, electropositive means metals. Metals are electropositive, we know that. Okay. If you are removing potassium from potassium iodide Ki, we will get I2. Okay. So that's also oxidation. If you are removing an electropositive element, that is oxidation. And also, if you are removing hydrogen from a compound, that is also oxidation. H2S is hydrogen sulfide. If you are removing hydrogen from hydrogen sulfide, that is oxidation of sulfide. Okay. So this is the way we can classify, or we can find out what oxidation reaction, how oxidation reactions takes place and all. Okay. So now it is reduction. In the case of reduction, what will happen? Addition of hydrogen or metallic element. That reversal of that oxidation thing. Okay, what we have studied for oxidation, just opposite, that is reduction. So if we are adding hydrogen or a metallic element, or remove oxygen or a non-metallic element from a compound, then we call that as reduction. Okay. So in redox reaction, what will happen? Oxidation and reduction takes place simultaneously. Such kind of reactions we are together calling as redox reactions. Okay. So reduction, we can see that addition of hydrogen. If hydrogen is added, that is reduction. Similarly, addition of electropositive element. See, Hg, mercury is electropositive, right? Mercury is a metal, liquid metal. So SnCl2 plus HgCl2, we will get SnCl4. Sn is tin, okay. Reduction of mercury chloride. Then if we are removing oxygen, ZNO, zinc oxide. From zinc oxide, we are removing oxygen, we will get zinc and carbon dioxide. So we are removing oxygen. And similarly, we are removing any electronegative element or non-metallic element. If you are removing, then it is considered as reduction. Here, reduction of ferric chloride. FeCl3 is ferric chloride. And also we need to note one more thing. We will always confuse with FeCl2 and FeCl3. Okay, this is ferrous. This is ferrous chloride. FeCl3 is ferric chloride. Oxidation state is higher than we will call as RIC, ferric. Cuprous also same. Copper also having different oxidation state. Cupric oxide is there. Cuprous oxide is there. Remember that RIC is coming, then it is having higher oxidation state. Here it is FeCl3 plus 3 oxidation state ferric chloride. So this is an example for reduction. So then now you have any doubts on oxidation or reduction reactions or not? Is it fine? Okay, we'll see with one example. Copper oxide plus hydrogen gives copper plus H2O. So we can see here from copper oxide, oxygen is getting removed. So if oxygen is getting removed, that is reduction. Substance which undergo reduction, that is the oxidizing agent. Okay, hydrogen, for hydrogen in the product side, if you are seeing means hydrogen got an oxygen. Okay, so hydrogen undergoes what? Oxidation. So that is the reducing agent. Substance which undergo oxidation is the reducing agent, and substance which undergo reduction is the oxidizing agent. So this is the sole thing we need to keep in mind. Then we can answer all the questions that we are getting this way. Okay, we will get questions sure for this example of reduction reaction. Yes, we have seen so many reduction reactions. See, Saint Devi. Here we have discussed all these reactions now. These are all examples of reduction reactions. See this slide. So here N2 plus 3H2 gives 2NH3. That is a reduction reaction. See, similarly, if you are adding an electropositive element, that is a reduction reaction. So these are the examples of for reduction reaction. Okay. So in redox reaction, what will happen? Both oxidation and reduction happens simultaneously. For example, without this complete equation, we can tell that, okay, reduction. Okay, we will tell Fe. With iron, we will tell Fe3 plus gives Fe2 plus 1 electron will be there, right? So this is an example for reduction because 3 plus is reduced to 2 plus. So this is a reduction reaction. Okay. Okay. Okay, so we'll see now exothermic and endothermic reactions. We know this clearly. The reactions in which heat is released is exothermic. If heat is absorbing, then that reaction is known as endothermic reaction. So this is the major difference between exothermic and endothermic reaction. If the system releases energy, heat energy, that is exothermic. Then if it is absorbing, it is endothermic. Okay. Then here we are having an example of exothermic reaction. Glucose reacts with oxygen to form carbon dioxide, water, and energy. So this is the basic reaction that happens in our body for the formation of energy, ATP synthesis. Okay. So what will happen? A lot of energy is released. So such kind of reactions are known as exothermic reactions. Endothermic reactions means heat is absorbing. We told that for the decomposition of calcium carbonate, we require a lot of heat. So that kind of reactions in which heat is absorbed is the endothermic reaction. Or else you think of one thing, like this calcium carbonate is basically marble. Okay. If you want to change this calcium carbonate to calcium oxide and carbon dioxide, simply it will not occur, right? We need much effort to do this thing, like conversion of calcium carbonate to calcium oxide and carbon dioxide. So what we will do? We will apply more heat. Then only it will get decomposed. So that way also we can remember. Calcium carbonate is basically marble. Marble, that decomposition, how we are taking, it will become calcium oxide and carbon dioxide in presence of huge amount of heat only. If we are supplying huge amount of heat, then only it will become calcium oxide and carbon dioxide. So keep in mind. So endothermic means it's absorption, absorb. Like that also we can remove. Exo, it's release. So small tricks also we can keep in mind to remember these things. Exo means release. Then endo, D, absorb. D and B, no, that correlation it will come. So like that also, if we are not remembering, we can remember things. So now we will see the effect of oxidation reactions in everyday life. So everywhere we are seeing means it's oxidation. So first is the corrosion. So corrosion is the process of slow conversion of metals into their undesirable compounds due to their reaction with oxygen, water, acids, gases, etc. So like that only corrosion will happen. How? If metals are exposed to atmospheric air, then this atmospheric air may contain different types of gases. Acids will be there, then water vapor will be there. So these atmospheric things will get combined with the metals, and some other different products will be forming. So like that, metals get eroded. That process is known as actually corrosion. So we can tell rusting of iron. We have seen, right, in home and all. If we are putting that steel staircase and all outside our home, we will see rusting of iron. So like that, iron react with oxygen and moisture to form red substance. So rust is having a red color. Okay. So that chemical equation is given: Fe plus O2 in presence of water. X is given because like X can be any integers, no, in like 1, 2, 3. Any number of water molecules can react. Then we will get ferric oxide. Fe2O3 is ferric oxide. Hydrated ferric oxide, we will tell. Rust is a hydrated ferric oxide. XH2O means that will be a number. X will be a number from 1, 2, 3, 4, 5, or 6, something. And ferric oxide. So we will call that rust as hydrated ferric oxide. Okay, that is what happening in rusting. Actually, our time is going. Like, do you have any other classes for classes today? Okay. Then I will take a little bit more time to discuss previous year questions as well. Okay. Okay. I'll try to complete as soon as possible. Okay. Be with me. Okay. How we can prevent rusting? First thing is, by painting we can prevent. Then by greasing and oiling we can do it. And by galvanization. Painting we know. Greasing and oiling also we know that process. Galvanization means, in galvanization, what we will do, we will cover iron or steel with zinc. The coating of zinc we are providing for iron or steel. That process is known as galvanization. Okay, so we can prevent rusting by painting, greasing and oiling, and by galvanization. Okay, that we need to keep in mind. And also, copper also get eroded. Copper is another metal. Iron was the first metal that we call as rusting. Now copper Copper is having a green coating. We will see sometimes copper vessels and all, old vessels and all, it is having green coating. So that is due to the corrosion of copper. So that green coating formed is copper carbonate. Copper carbonate, what is important with copper carbonate is it will not, it will often occur with copper hydroxide. CuOH twice is copper hydroxide. So these two compounds occur together. So copper reacts with the carbon dioxide plus oxygen in the presence of water. We will get copper carbonate. That is responsible for that green color. So, and this copper carbonate will always be with this copper hydroxide. We need to keep that one in mind. So this is about corrosion of copper. Then next is silver. Silver turns to black. Okay, so what will happen? Silver is exposed to hydrogen sulfide gas. There are too much of harmful gases in atmosphere. Like that, hydrogen sulfide is another gas present in atmosphere. Okay, so silver. Chemical symbol for silver is Ag. We need to know this one. Ag is silver. Au is gold. Okay, don't get confused. Au is gold and Ag is silver. So Ag plus H2S. Ag is reacting with H2S. We will get Ag2S and H2. Okay. So this way only silver metal is getting corroded. So that black thing that is seen here, we can see now that is seen above the silver thing is Ag2S. Silver sulfide. So how same way we can prevent that corrosion of silver metal also. Same copper also we can prevent the corrosion by painting, galvanization, or using oil and grease. So next is rancidity. So regarding metals get corroded. For food that containing oil and fat, it will get rotten after some time. So that we will call as rancidity. Okay, rancidity. The taste and odor of food materials containing fat and oil changes when they are left exposed to air for a long time. If you're keeping fat and oil food for a long time in air, it will get rancid. Okay. It is because of the oxidation of fat and oil. Usually oil and fat get oxidized. Because of that only, it will become rancid. So how to prevent rancidity? There are many ways to prevent rancidity. We can use inert gases in packing. Why we are using inert gases? Inert gases means, I will tell you, noble gases are there. In addition, we will use nitrogen. N2 is a gas now. In N2, what will happen? Why it is used? N2 is having triple bond na? N triple bond N. So this breaking this N triple bond is very difficult. Like it is a strong bond. So that nitrogen is considered as an inert gas. So using inert gases in packing, we can use nitrogen, helium, etc. So like in this case, when we are telling inert gases, don't solely think of noble gases. We can have nitrogen as well. That's why. So why nitrogen is unreactive? Because of the strong triple bond in nitrogen. So this is a fact that you can keep in mind. Okay. Then using oxygen scavengers. There are certain substances that can absorb oxygen. So like that, we can prevent rancidity. Then we can keep in refrigerator. Then we can store in dark places. We can use airtight containers. Vacuum packaging we can do. And antioxidants we can use. Okay. So now, do you have any doubts over here, like from oxidation redox reactions oxidation, reduction, reducing agents, then oxidation in everyday life. Do you have any doubts in any of these things that we have discussed so far? Okay. Okay. Uh, Devi is asking, like, what's the full form of BHT? BHT is butylated hydroxytoluene. Hydroxytoluene, toluene, you know, you actually, we have not studied that much big structures, okay? BHT is butylated hydroxytoluene. Toluene is benzene ring, you know, right? Wait. So benzene ring, we know. So this is benzene. Toluene is benzene ring having one CH3 group. Okay, that is toluene. Butylated hydroxy means one butyl group will be there and one hydroxy. Butyl group will be there and one hydroxy group. Hydroxy is OH group. Butyl group is CH3, CH2, CH2, CH2. For space issue only, I have written butyl. Okay, so butyl hydroxytoluene, butylated hydroxytoluene. So these butyl groups may be coming in different positions. Okay, that position is not specified. It will be coming in different positions. But toluene is a compound having this benzene ring and CH3. If benzene ring and OH, this alone is coming, OH alone is coming, then it is phenol. This compound is phenol. This compound is phenol. This is hydroxy. It is coming a substituent. That's why we are calling it as hydroxy. If it is a major, then we will call it as phenol. Okay. So BHT is us. Okay. So no other doubts, right? Okay, we'll discuss some of the questions then. Okay. So first question is, why does the blue color of copper sulfate solution changes to green color when an iron nail is dipped? Write the chemical equation. So copper sulfate solution is having a blue color. When we are putting an iron nail to it, actually these questions is already asked previously, okay? So we need to understand these questions. Similar questions we can expect in this exam also. So blue color of copper sulfate solution. Copper sulfate is CuSO4. CuSO4 aqueous. If you are adding Fe, what will happen? Blue color of copper sulfate changes. So product formed will be FeSO4 plus Cu. The balanced equation we will see in answer. So this is the reaction. Actually, we will get ferrous sulfate. Instead of copper sulfate, we will get ferrous sulfate. That is the reaction happening, and we will get copper. So iron, we will see in this figure. Okay, next figure we will see that copper get deposited on iron. You can see here, copper metal get deposited on iron, and green iron sulfate solution we will get. FeSO4 solution we will get. Okay, so this is the thing happening actually. The next question. This is understood reaction, and we have written phases also. Iron is solid, right? Copper sulfate is aqueous. When this iron nail is covered with copper, so copper will be solid only. Then FeSO4, it is formed in that solution. That's why it's aqueous. Okay. Okay, let's see the second question. Okay, what is observed when a solution of potassium iodide is added to a solution of lead nitrate in a test tube? Okay, we got this reaction before, right? In the starting itself. Solution of potassium iodide, Ki. Ki reacts with the to a solution. Here it is given as solution, so phase is aqueous only. Plus potassium iodide is added to a solution of lead nitrate, PbNO3. PbNO3 twice will be there. Like usually lead is having a valency of 2, that's why. NO3 is a single valent, okay? That is also aqueous solution. We'll get here PbI2. That PbI2, it will be solid, and KNO3. So this KNO3, it is aqueous. Usually, I'll tell you a tip. This nitrates, no. Nitrates are always soluble in water. So it will be aqueous. So potassium nitrate, this is aqueous. Ki. We will check whether this equation is balanced or not. Okay, here there are 2 nitrate, no. So we'll give 2 KNO3. So potassium will also will give 2 Ki. Here now we are seeing K, 2 K are there, I, 2 I are there. Okay, nitrate is there, and also Pb, 1 Pb. So for balancing, what we need to do? We need to first focus on which is that atom that is having more number. Okay, so like that we can balance. So what type of reaction it is? It is a double displacement reaction. So double displacement, Anna. It's a double displacement reaction. Okay. So PbI2, it is a yellow precipitate. Yellow precipitate of PbI2 is forming. So next question. Dilute solution of ammonium hydroxide is added to aqueous solution of ferrous sulfate. We will get ferrous hydroxide. What type of reaction is this? And chemical equations. This is also a double displacement reaction, and equation is like this. FeSO4, ammonium hydroxide, NH4OH. Ammonium hydroxide gives ammonium sulfate plus FeOH twice. This ferrous hydroxide ആണ്. Ferric hydroxide അല്ല. FeOH thrice ആണ്. Ferric hydroxide. This is ferrous hydroxide. This is ferrous. Okay, ferrous hydroxide. Ferrous sulfate plus ammonium hydroxide. Ammonium, this no. It is also a polyatomic ion, NH4 plus. Okay, this is ammonium. Ammonium. Okay, this is ammonium. OH is hydroxide. H and OH we already know, right? Okay. So next. So in this reaction, identify the oxidizing and reducing agents. Okay. So MnO2 we can see here. Okay. Oxygen is removed from MnO2. So this undergoes reduction. This reaction is reduction. Who is undergoing reduction? That is the oxidizing agent. This is the oxidizing agent. So from here we can see HCl. Hydrogen is removed from HCl. So that is oxidation. Okay. So this is the reducing agent. reducing agent. So this is the way we find oxidizing and reducing agent. The explanation is also provided. You can read it out. The next one, what change in color is observed when white silver chloride is left exposed to sunlight? Silver chloride, AgCl, we are exposing that is a photochemical reaction, okay? Sunlight, right? So it is a photochemical reaction. It is also a decomposition reaction as well. Photochemical reaction, we told initially, that is an example for decomposition reaction. So we'll get AgCl gives Ag plus Cl2. And here we are having 4 questions. These questions have asked in different years, okay? Okay, Joseph Andrew has asked a question like, NH4OH is a base. Yes, NH4OH is a base. Ammonium hydroxide is actually, it is a basic salt. Ammonium hydroxide. NH4OH. It's based on doubt, okay? Don't think anything, okay? NH4OH is a basic salt. We can treat this one as a base as well. So in certain reactions, when we are adding ammonium hydroxide for getting that basic nature, okay? So that's considered as a base. So at any cost, you have to study this question completely, like on what basis a chemical equation is balanced. A chemical equation is balanced based on the law of conservation of mass. Total mass of the reactants reacted will be equal to the total mass of the products formed. So this is the basis of balancing chemical reaction, law of conservation of mass. Don't forget this. So the basis of balanced chemical equation is law of conservation of mass. Here we can see that 30 kilogram of log we are putting for 1 kg fire, we'll get 28 kg ashes and 3. Total here reactant side it will be 31 kg. Here also it is 28 plus 3, 31 kg we'll get. Okay. So next question is, a housewife wanted her house to be whitewashed. She brought 10 kilogram of quicklime from the market and dissolved in 30 liters. Hello, can you hear me? Hello. Okay. Sorry, connection got disconnected. That's why. Okay, let's proceed. Okay, this we have already discussed. Reaction of quicklime with water, we'll be getting slaked lime. So this reaction happens with the release of large amount of heat. That's why water has started boiling. Okay, so that is the reason, and we can have that equation as well. We already wrote that equation. Calcium hydroxide, calcium oxide plus water gives calcium hydroxide plus heat. Okay, so next one. Next question. Okay. Balance the flowing chemical equation. We are having a chemical equation to be balanced. FeSO4. Okay. This, what we need to do, we need to check which ions are not balanced. Fe, there is one Fe in reactant side, product side, there are two Fe. Okay. Sulfur we are seeing means one sulfur, two sulfur is there in reactant product side, but only one is there in reactant side. So what we will do, we will give, first we will try to balance Fe. Okay. Two Fe is in product side, right? So we will give reactant side also 2Fe. So when we are checking, okay, it will become balanced. When we are seeing oxygen, it is balanced. If there are 4 oxygen atoms in FeSO4, so totally it will be here 4 into 2, 8 oxygen atoms will be there. Oxygen atoms will be 8. Here also 3 are there. 3 plus 2, 5 plus 3, 8. 8 oxygen atoms will be there. So that is also balanced. This is the way we have to balance. Less common atoms we need to balance first. So here it was Fe. First we will check Fe atoms it's balanced or not. Then based on that we will give. I hope that you know how to take atoms. Like these are compounds now. So we should not balance these places. This subscript you should not touch. When we are considering FeSO4, if it is having one Fe atom, one sulfur atom, and 4 oxygen atoms. One FeSO4 molecule is having one Fe atom, one sulfur atom, and 4 oxygen atoms. This you have to keep in mind. The product formed, it is also having 2 Fe atoms and 3 oxygen atoms. This you should not touch. This subscript you should not touch. You can balance giving coefficients only, chemical coefficients only. We will call these numbers as stoichiometric coefficients. We can give only stoichiometric coefficients, not this numbers. Okay. So next, balance the flowing chemical equation. MnO2 plus HCl gives MnCl2 plus Cl2 plus H2O. MnO2, we can here check. Okay, manganese atom, one manganese. Reactant side, product side, that is balanced. So then we will check oxygen. Oxygen 2 are there. Here, 1 is only there. So we will wait for the next uncommon atom. Oxygen and hydrogen are common in all reactions, right? Almost all common in all reactions. So we will check for chlorine. So chlorine, only one chlorine it is here. There now we are seeing here means 2 plus 2, 4 chlorine atoms are there. So we will take the more element which is having more number of atoms. So we will take chlorine. Here it is 4 chlorine in the product side. So what we will do, we will give 4 chlorine in reactant side also. So we'll give 4 HCl here. So then we will check. Okay, when we are giving 4 HCl here, this hydrogen become 4. We will check here it is 4 or not. It is only 2. So if you are giving 2 means this will get balanced. Okay, H2. So 4 number of atoms are hydrogen atoms are there. Now we will check every other things are balanced or not. It's balanced only. Okay. So this is the way we need to check. First, less common elements we will take, and we will check that that is in more in number or not. If that is in more number, then we will go with the atom that is in more in number. Okay. So like that. Okay. Okay. Balancing is understood, right? Sixth problem. Same way I will explain. I'll explain sixth problem. Okay. Sixth question was, what is the basis of balanced chemical equation? state the law on which a balanced chemical equation is based, or state the law of conservation of mass, or on what basis a chemical equation is balanced. Okay, we will take a chemical equation. Okay, for example, we'll take the simple one. Okay, formation of water. We'll take the formation of water. Okay, H2 gas plus O2 gas gives H2O liquid. So we will balance this. Okay, so in this reactant side, it is 2 hydrogen, product also 2 hydrogen. When we are checking oxygen, here it is only 1 oxygen, here it is 2 oxygen. So we will give 2 in front, 2 is a stoichiometric coefficient, we will give to water. So now that number of hydrogen got changed now. So we will balance hydrogen as well. So this is the balanced chemical equation for the formation of water. So mass of hydrogen, that is 2 gram. Okay. That is for H2. For 1, it is 1 gram. For H2, it is 2 gram. And there are 2 molecules of H2. Similarly, if we are checking here, oxygen, it is 32 gram. So 4 gram here plus 32 gram. We will check 1 molecule of water, it is 18 gram. So here it is 2. 2 into 18 means it is 36 gram of water. Here also 32 plus 4, that is 36 gram. Okay, so total mass of reactants, you can see here, total mass of reactants is 36 gram and total mass of product is also 36 gram. So we can tell that law of conservation of mass is obeyed. Like according to law of conservation of mass, the mass can neither be created nor be destroyed. Here, mass we have not created or we have not destroyed. So we told already, no, in chemical reactions, what is happening? Only that interchange of atoms only taking place. There is no change, no other change. Okay, so here it is 36 gram, formed is also 36 gram. So mass is not created or not destroyed. So that is what mentioned in law of conservation of mass. So balancing of chemical equations is based on law of conservation of mass. Okay. Okay. We will see that answer. For answer, I have given that example like so here no. So for our question, on what basis that balancing of chemical equations that we are doing? So it is based on law of conservation of mass. So in this 30 kilogram of log, and we are taking 1 kilogram of fire, like quantitatively for saying an example only we have taken this. So totally in the reactant side, that is there is 31 kilogram, 30 plus 1 total, it is 31. So reactant side, that is 31 kilogram. In this place, product side also we are having only 31 kilogram only no formed. So 28 plus 3, it will be 31. Okay, 28 plus 3 is 31 only, right? So the product side also same amount. The total quantity of total quantity of product formed is same. So this one we need to understand. Saying the way is it okay? Like have you understood this thing? How that balancing of chemical equation, it is based on law of conservation. If you are writing any chemical equation, it is based on law of conservation of mass only. all the balanced chemical equations, if you are checking the reactant side total mass and the product side total mass, it will definitely obey law of conservation of mass. Okay. Okay. So if you have any other doubts, means you can ask. Any other doubts? This is the time for you. If you have any doubts, means you can ask. So this is the time for you. If you don't have any doubts, let's wind up. It's already 7:30. We'll see in next class. Okay. Is it fine for everyone? Hope you have understood. If you have any doubts, you can ask me now. Okay. Okay. Then let's wind up. For next class, come up with all your friends and get ready. Okay. Thank you. Thank you, everyone. Thank you all.